After 4 redesigns in the initial 6 months of the development of our application, our code base was a mess. We ended up with a God stream fragment that had several thousand lines of code, and that was in charge of 3 different user flows. And not only that it was talking to the model, it even ended up saying, telling to the database what to save. So when our product owners told us that, hey, you need to implement the 5th redesign, we knew that we can't continue like this. We knew that we need an architecture that allows us to react quickly to the design changes that were expected from us. We knew that we needed a good code base. So what is a good code base? What are the properties of a good code base? Whatever you have in mind, I'm pretty sure it includes one or more of these words. It's robust, stable, with both UI and business logic testable, modular, and easy to extend. I want to tell you today about 3 different user patterns that can help you achieve this good code base. The model view controller, the pattern that we initially approached, the model view presenter, the one that we could have applied, and the model view model, the one that we ended up applying. I want to tell you exactly what these patterns are, what's the difference between them, and most of all, I want to answer some of the questions that I'm pretty sure all of you have. So, model view controller, model view presenter, model view model. They all have 2 elements in common, the model and the view. And the role of these 2 elements is actually pretty much the same throughout all of these patterns. The model is the one that's in charge of the business logic. It's going to be the one that talks to the network layer, talks to the database layer. So this is the part where, for example, you'll get some data from your backend. You would save the response in the database, maybe do some caching, some offline optimization, and then the model exposes that data to whoever needs it. The model is completely independent from Android, and therefore it's easy to unit test using JUnit. The view is the one responsible for displaying the data. The controller, the presenter, and the view model are working with the model to get the data. And the view is working with the controller, the presenter, and the view model. But the way this happens actually is pretty different. So, model view controller is pretty much the oldest pattern in the book. It was developed by desktop and web programmers in order to split their code a bit better, to make it more testable. So in model view controller, we have a view that talks to a controller and with the model, and a controller that has a reference to the view and to the model. Let's see a bit what's the flow of the information to understand better what are the responsibilities of these elements. So the controller is the one that gets the user input. Then it updates the model. Once the model has been updated, the controller will tell the view that it should update. And then the view will request the latest data from the model and display it. Well, that sounds pretty good. Things seem separate. Well, I remember around 2011 when I had my first Android interviews that I was asked, so how do you apply model view controller in Android? And the answer, the correct answer at that point, was that in Android, an activity is both a view and a controller. But wait, if MVC was created in order to split the responsibilities and make the code more testable, how is this more testable? Okay, the model is testable, but how about the controller? And I think the reason why a lot of developers did this mistake is because they saw that the controller is the one that handles the user input. So they thought that, okay, the controller should be the one that implements that on-click listener. So therefore, that should be the activity. That should happen in the activity. But actually, to make this testable, what we need to do is get that controller out of that activity. So rather have the view that handles the user input. So we should have a flow that looks something like this. The view gets the user input. It tells the view about that user, it tells the controller about that user input. Then the controller updates the model. Once the model has been updated, the controller will notify the view that it should update, and then the view will request the latest data from the model. Okay, this sounds better. The controller is separate. Things should be more unit testable, right? but still, the controller has a reference to the view. If that view is an activity, then it's still harder to implement the JUnit tests. The solution for this is pretty simple. Just create an interface for the view and have the controller have a reference to that interface. Okay, but we know that the model handles the business logic, but who handles the UI logic? So let's take an example. Let's say that we have a user that has a first name and a last name. What we need to display is the display name on type last name, comma, first name. So if we have, for example, a user called Jane Doe, what we need to display is Doe, comma, Jane. So who should do this logic, this display name logic? Should it be the view? Should we have in the view just a retrieval of the user from the user model and then construct the display name and set it to the text view? But we said we want the UI logic to be testable. How is this unit testable? Okay, but we know that the model is unit testable, so we can put that in the model, right? So in the model, we can have a getDisplayName method that does this. We can unit test that. That sounds better, right? Well, not quite. The model should actually handle the business logic. Why all of a sudden the model should know about the UI logic? Well, actually, in general, the view ends up knowing too much because the view knows about the controller and about the model. And actually, these were the mistakes that we made. We had the fragment doing all sorts of things, deciding what should be displayed, when should be displayed, and we started first with the user flow, then we added another one, and then another one. And then since the fragment was anyway talking to the model, why not make it talk to the database also? It was a mess. So if you already have mess under the carpet, don't just add some more, clean it up. So the solution for this would be to actually break that connection between the view and the model, and rather use another class, use the controller to actually handle everything, to have the controller maybe get the data from the model, apply the UI logic on top of it, and then tell the view what it should present. Well, actually, this is the model view presenter pattern. In model view presenter, we have a view that has a reference to the presenter and a presenter that has a reference to the view and tells the view what to display. Also, the view notifies the presenter about the user actions, and based on this, the presenter decides what should happen next. If the model should be updated, if the view needs to be updated. So what developers tend to do is to create an interface contract where they have an interface for the view and the interface for the presenter. Like this, the entire logic, the relationship between the view and the presenter, the corresponding presenter, is held in only one place. So this means that for our example, we would have an interface for the view where we would have a method setName. And then in the presenter, we would have two members, the user model and the view. Those objects would be given as a parameter to the constructor, and then would use them as references. So in the presenter, we would also need a sort of a start method, a method that the view would call when it's ready to load, when the view would be ready to display the data. So let's call it onload. This onload method should be the one responsible for creating that display name. So in onload, we would get the user from the user model, compute the display name, and then set the display name to the view. To test this, it's pretty simple. All we need to do is mock the user model and mock the view, and then give those mocked objects as parameters to the presenter. Then, in order to check that indeed the display name is called when onload is called, we define what should happen when we're requesting the user from the user model. And then we're checking that indeed when onload method from the presenter is called, the setName method of the view is called with the correct parameters. Okay, so if this is the schema for MVP, what if we look at this a bit from a different perspective? What if we look at this from an event-based point of view? So then this means that the presenter will be the one that produces data, and then the view would be the one that consumes data, right? So this means that every time the name would change, the presenter would just emit a new event for that. Okay, but if the presenter is the producer, why should the producer know about the consumer? Why should we have in the presenter actually telling the view, hey, set this name? The producer shouldn't care who consumes the data. But rather, what we should have is just a stream of events that whoever needs it, whoever wants it, can just subscribe to it. So this can be done in Android in a lot of ways. One would be with the Android data binding library. But our approach is with the help of RxJava observables. So what we're doing is just exposing a stream of names, and then the view can just subscribe to it. And every time a new name is emitted, then we're just setting that name as a text for a text view. So this means that actually in the presenter, we no longer need the view. And actually this also means that we don't need the set name method in the interface of the view. This means that the interface for the view is no longer needed, the interface for the presenter is no longer needed, and what we're left with is the model view model pattern. The model view model pattern was introduced by Microsoft in order to simplify event-based implementation of user interfaces. So in MVVM, we have the view model that gets the data from the model, it applies the UI logic, and it just exposes it to whoever needs it. It can be the view, it can be the tests, or any other classes. And then the view would just subscribe to the view model. Okay, remember our example? Let's complicate it a little bit. Let's say that apart from the first name and the last name, we also have the date of birth. So for example, we would have Jane Doe with the date of birth, 4th of April, 87. But what we need to display is the display name with the same logic and the age. Probably at the beginning you would be thinking that, well, that's simple, we just expose two observables, right? One for the name and one for the age. But actually, what the view model does is expose a state of the view. So we should just encapsulate these two elements into only one field, in a displayable user, for example. Like this, the view model exposes a model for the view in the app. Again, to test this is pretty simple. We again mock the user model, we give this object as a parameter for the view model, and then to test if indeed when we're subscribing to get user, we get the correct value, we're defining what should happen when we're getting the user from the user model, and then we're subscribing to the events of the get user. And then we're checking that indeed the correct data has been omitted. Okay, so MVP and MVVM. We pretty much found out what are the differences between these two patterns. We know that the view, the presenter is working directly with the view to set the name, for example, and then in MVVM, the view model just exposes streams of data that whoever needs it subscribes to it. But if the differences are pretty clear, actually MVP and MVVM are quite similar in the way they are applied. So I want to give you the answer for several questions that I'm pretty sure you guys have in terms of these two patterns. So who is actually the view? Well, actually, the view can be an activity that has its own presenter or view model. But it can also be a fragment with its own presenter or view model. Or even custom Android views can be the views in MVP and MVVM. Okay, when we look at this, we see that this looks actually pretty good, right? So the classes are quite separate. It looks like the views know about the presenters, and that's pretty much it. Well, actually, this is pretty cool, and this is also easily achieved in Android with the help of dependency injection. So you would have probably, let's say, if you're using MVP, a view where you would inject the presenter, and then you would just set somewhere presenter on load of the view. If you have a view model, things are even simpler. You just inject the view model, and that's pretty much it. So this means that, let's say you have a fragment that has some view and another view. In the XML, you would have, let's say, a relative layout that has a reference to this some view and another view. And actually, that's it. No one knows about these presenters or view models. So this means that if you want to replace some view with a new view, all you will need to do is replace the data in the XML. That's all. So that's pretty cool. This separation of concern is really nice with MVP and MVVM. But how do you actually decide how to split these views? Well, just think of the normal POJOs. What are you thinking when you need to decide how to split a POJO? Probably you have in mind the complexity of that Java class, the responsibility, and then the reusability. So just apply the same principles to the view also. When you see that the view becomes too big, when it does too many things, or when you see that you can reuse it, just split it and create their own presenter or view models. But then, when you're creating those presenters and view models, how do you decide what goes where? So let's say that you have some piece of code that you need to implement. How do you decide what goes in the view and what goes in the presenter or the view model? Well, actually, the testability of MVP and MVVM help us with receiving the answer to this question. So just think about that piece of code that you need to write. Does it contain any UI logic? If yes, definitely needs to go in the presenter and the view model because it needs to be tested. If not, just put it in the view. But when you're moving all that logic from the view to the presenter or view model, you might actually tend to have a new God class. It won't be the view, it will be the presenter or the view model. But don't be afraid of small classes. Just create separate classes that have their own responsibility and that can be unit tested. And that's it. Okay, so if we have multiple views, what do you do if these views somehow depend on one another? How do you handle these dependencies? So let's say that you have a fragment that has view 1 and view 2. So in your app, this would look something like this. In the top part, you will have the view 1, and the bottom part, you have view 2. In the view 1, you would have some edit text, and only when all of these edit texts are filled, a button would be enabled. But view 2 doesn't know anything about view 1. How would view 2 know when all the edit texts have been filled? Well, first of all, just look at your code and take a step back. What are you doing with that data? Are you putting that data somewhere in the model? Because then what you need to do is just have one presenter or view model saving the data in a data model object, and then another presenter or view model just reading that data. But if it's not the case, if actually things just happen on the UI part, then just create a presenter that implements these two other presenters. Or if you're using a view model pattern, the MVVM pattern, then just have a view model consuming the events of the other view model. That's all. How about the Android lifecycle? What are the roles of the Android lifecycle in MVP and MVVM? Well, let's start with on resume and on pause. I was saying something about the onNode method, but I never said what it's actually called. Well, actually, on resume, this would be the place where the view says, OK, presenter, now I'm ready to load the data. And then on pause, it would be the place where the view tells the presenter, OK, I don't want to present anything else. That's it. I'm done. Similar in the MVVM pattern, in on resume would be the place where we're subscribing to data. And then in on pause, where we are unsubscribing. But this applies for, for activities and fragments. What do we do if we have views? The views don't have on resume and on pause. Well, actually, the answer is pretty simple. We just use on attach to window and on detach from window. On attach to window, we just call presenter on load, so the initialization method, and then on detach from window, presenter on stop load. Similar for MVVM, we would call view model subscribe, and then on detach from window, unsubscribe. Okay, but what do we do if we support rotation? What do we do for configuration changes? Well, we just use on save instance state and on restore instance state. So on save instance state, this will be the place where we would get the state from the view model or presenter and then save it in that bundle that the framework gives us. And on restore instance state, we just get the data from the bundle and then put it in the presenter or the view model. This happens okay for an activity, for example, but if we have a view we wouldn't have that bundle, but rather we would need to work with parcelables. So this would mean that whatever state you want to save, this has to be parcelable. It might sound complicated, but nowadays, with the help of all of these open source libraries, like AutoParcel, for example, this is pretty easy to do. For us, MVVM was the right solution. It helped us have exactly that separability that we wanted, this testability. And then this was proven when we had yet another redesign. But MVC versus MVP versus MVVM. Which one should you use? Actually, it doesn't matter. What all these patterns do is just create a common language between you and your team. So then when you're saying presenter or view model, everyone in the team knows what you're actually talking about. Also, whatever you decide to choose, just pick one and then be consistent. Like this, you ensure that the code is more readable, more easy to extend because you already know how the framework, how the feature works, for example. And yeah, it's easy to get new people working on it when everything is based on the same idea. And don't be dogmatic. The thing is that wherever you get to apply, you'll end up changing it. You'll end up bending the rules to suit your needs, to suit the libraries that you're using, and the level of knowledge that you have. But wherever you get to choose, have these questions in mind. Are your Android classes logic-free? Can you unit test everything? And do your classes do one thing and one thing only? If you can answer with yes to all of these three questions, it means that you have that robust, stable, testable, modular, and easy to extend application that you wanted. Thank you. I think we have time for questions. Any questions? No. Okay. Laura? Yeah.
So does it encourage to prevent null from ever happening in like presenter or view model?
What do you mean encourage to from?
Like, just always prevent null. Like always have a default value for anything and everything that's going to be passed into a view. Is that like not a part of these patterns at all?
I don't understand what you mean.
Might be something more like I think they're called like value objects, or if we can call that, where it's
like a what?
Value objects.
Okay.
The idea is like if you have view.setText, you never want null going into that setText method. So I was wondering if there's like a presenter or view model pattern that specifically prohibits that, or like has that as a concern.
From what I know, it's not, but that's the thing. You can ban these patterns and then just make sure you apply them as you need it. So for example, what I was using at one point with this is have a default view. Do you mean like when the rotation happens or when there's no view that the presenter can load? This is what you mean? Yeah, so what we did is we had like a default empty view implementation, and whenever the presenter didn't have the view to load, it was actually working with that fake view, so actually it wasn't doing anything. So then there wasn't anything to be set.
Did you ever use fake models of that also?
Mm-hmm.
It's like, oh, okay.
No.
All right, I think that answers it. Thanks.
Okay, so you said you rolled out the interfaces for the view.
Yeah.
And then that means that you have a connection with the presenter.
Well, what the throwing out of the view, the interface of the view was actually the introduction to the view model, because in the model view model pattern, you don't need an interface for the view because there's no one to use that interface. There's only one implementation of that view, so then there's no need of an interface for the view.
Okay, so when you subscribe, you held a reference to the view,
well,
Android view.
When you subscribe in the view model doesn't know who consumes the data, so the view model doesn't have a reference to the view.
But when you said that you want to subscribe and then fill the data, it was in subscription.
Yeah, so the view would subscribe to the view model, yes. But then why do you need an interface for a view?
Yeah, I'm just asking because then you would have to have the reference on your view in your presenter.
No, you don't. In MVVM, you don't need it.
Oh, okay. Thank you.
That's the main idea, because in model view presenter, the presenter tells the view directly that, hey, this view needs to set this text, whereas in the view model, you're just exposing data, and then whoever wants it, for example, a view subscribes to those emissions and then sets the data correspondingly.
So basically, cyclic architecture, when you call it, it goes in circles.
Why would it go in circles?
When you get me the data and it's subscribed,
Yeah?
it will receive the data
Yeah.
anyway. You
Yeah.
don't unsubscribe anywhere.
No, the unsubscribe happens on pause.
But if data changes in real time, what happens?
Yeah,
then?
so if the data changes, this means that that observable in my case would just emit again. So then
That's
it
what
emits
I'm
again,
saying,
so
yeah.
then the view, since it's subscribed, it will automatically set that text with the new data that gets to be emitted.
Yeah, okay, so it's cyclic.
Yeah.
Yeah, okay, thank you.
Mm-hmm. Sure.
So if you've got a kind of complicated view with a whole bunch of different things in it, what's your take on, just in terms of like performance, a couple of different things. One is if you've got something like, I just need to update a loading spinner and maybe there's like 20 fields. If you encapsulate all that stuff in a view model, and every time any one of those things changes, you're actually updating the whole thing.
Yeah.
You know, either you have to put more logic in the view to go through and say, I'm only going to actually update the UI if something changed, which complicates the view, or you maybe, you know, just, what's your take on the performance versus granularity, I guess, there?
So what we did, for example, was exactly this. So every time something was updated, we would update the view. So if you have more fields. But then I think it depends on the case. So if you can split that view into smaller views, then it's even better. Then you don't have that performance problem. If not, I would say you just decide what to do. For example, what we had is a list. And then the adapter would be the one that would decide, okay, only this element should be updated.
Sure.
Yeah. Cool. Thank you.